Hey guys, and welcome to another lesson in our Introduction to Pandas series. So in the last lesson, we learned about all the different tools and techniques available in Pandas library to help us explore our data. We learned how you can select specific rows and columns and how you can add filters and conditions to select specific subsets of your data. And also what functions you can use to sort and aggregate your data frame. In this lesson, we will be moving to another type of exploratory data analysis, which is more focused on data visualization. So let's check our lesson number 9. We start to talk about how you can visualize your data in Pandas. As you guys know, data visualization is an important aspect of every exploratory data analysis. It helps data analysts to summarize a very large amount of data using visual elements that provide you with a better understanding of your dataset. But although the Pandas library is not specifically designed to be a data visualization tool, it has some very powerful and useful tools to quickly create clear and cool visualization elements. In this lesson, we will focus on two types of data visualization. First one is creating graphs such as histogram, pie chart, time series, box plots, and so on. And second one, we will focus on table visualization, which is basically using some sort of HTML and styling option to highlight specific parts of your data frame based on a predefined condition. So the main tool we will focus on for data visualization is the plot method, which can be applied to a Pandas series or data frame object. This method has a lot of built-in parameters. And to learn more about all these parameters in the plot function, we can click on the plot function link documentation page. Here we can see all the different parameters that we can use in this lesson. For example, we will need to identify the name of the data frame, the x and y variable, and most importantly, the kind parameter, which has a lot of different types of plots to display different types of visualization. And also there are so many other parameters. So let us start to learn how to create some popular data visualization graphs. Our first plot is called the time series graph. Time series graphs are a very popular visualization method to show how any value moves through time. We can see this graph applied a lot in financial market data or to track the price movements such as oil price or gold price and so on. So let us start to use an example about visualization time series data representing the size of air travel passenger datasets through the year. We will download this dataset from GitHub using this code. And we can visualize this dataset to see how it looks like. We notice in this dataset we have two columns. The first column represents the date, which is basically 1 month interval starting from 1949 forward. The other column represents the number of passengers aggregated by thousands. In order to make use of this data frame to make time series plot, we need to do a little bit of data manipulation. Basically, we need to move the month column to be our index value. If you remember how we can do that, we can make it as an index using the setIndex function. Okay, so now the column month was assigned as the index value. We can have a look at the data frame and see how it looks like. And we see the month column was moved to be the index value. So now we can start to plot this data frame. Notice how we use the plot function using default options and without adding any parameters. So the function generated this time series plot, or what is known as the line chart, which is the default behavior of the plot function. But let us try to change the size of this plot using the figure size parameter, which take the height and width in inches. So we select the size we want and run the cell to make the figure look like a little bit bigger. This example shows you how easy it is to actually apply the plot function once you have your data frame ready and all data are in the correct shape. Another common data visualization scenario for data analysts is to explore the relationship between two different variables to see if there are any kind of positive or negative relationship, or if they have any impact on each other. The most common type of visualization is something called a scatter plot, and this scatter plot helps us to visualize this type of relationship. So in this example, we will use a dataset called iris dataset. This dataset is basically about 3 different types of flowers, and we will try to explore the relationship between some variables in this dataset. Let's have a look. After we display the data, we notice there are 5 different columns. 4 of them are numerical values for sepal length and width, petal length and width, and the last column represents the species of the flower. Okay, let's try to explore the relationship between 2 of these variables using a scatter plot. And we need to assign few parameters for the plot function to make the visualization. The first parameter is kind, which basically is to identify the figure as the scatter plot. And then it's need to identify the values that represent the x and y axes. And finally, we add the size of the figure. So we run this cell and we notice here there are some sort of positive relationship between the 2 variables. The higher each value, the other value will go also higher. The scatter plot usually can give a lot of useful information to a data analyst about the relationship between the variables. What data professionals usually do is to apply some sort of coloring scheme to highlight different data dimensions. So here we have variables based on the x and y axes, and by using different colors for different values, the plot function can give us another dimension and depth to our data visualization. So let's try to do that. How about we color different groups of dots based on their species value? To do that, we can again change the parameter in our plot function to specify these color values. Let us first create some sort of a coloring scheme. In this example, we basically assign a color value to represent each flower species value type. In other words, we tell the parameters that the species Setosa has the blue color, the versicolor has the red, and the virginica has the yellow color. And now, let's apply that color scheme as a parameter to our plot function. You see here we actually use a different parameter, the parameter C, which is used to interpret the color scheme that we created earlier. We now run the cell, and we see here our changes replace each flower species with its corresponding color scheme. This flexibility already gives the data analyst a much more depth and information and understanding about their data. So here we have learned how the Pandas built-in plot function can be used to explore and change so many different types of data visualization. Another thing we can also do with the Pandas library is actually to apply some sort of coloring and styling within our DataFrame objects. What we can do here, for example, as you display your dataset in a DataFrame object, you apply some sort of coloring and styling setting to this DataFrame. Let's have a look at this example. So this code here should look very familiar. We basically sorted our data frame based on a specific value. In this case, it's the sepal width. What we can do now is to add some sort of styling on this data frame. We see in this code we added the styling option, which is basically you add some sort of CSS element if you are already familiar with the HTML development. It's basically adding a bar chart on the variable sepal width. So let's run the cell. We see here it actually just added a bar chart to visualize how the values are moving for sepal width. And remember, this can actually be added to any data frame. So in this lesson, we learned about two main techniques that are available in Pandas library to help users visualize data either as a graph, such as pie chart, bar chart, time series chart, or scatter plot, or as a coloring style inside a data frame object. In the next lesson, we will get a chance to apply everything we learned so far in this crash course on a project that involves collecting and analyzing real-life dataset. So please stay tuned.